Hey there, how's it going everybody? In this video, we're going to be learning about UV, which is a new package manager for Python that's growing pretty quickly in popularity. Now, the goal with UV is pretty ambitious. They want it to be a single tool that can replace pip for installing packages, venv or virtualenv for creating and managing virtual environments, pip-tools for generating lock files, and even pipx for installing and running Python tools. UV combines all of these tools into one, and also it's quite a bit faster than those other options since it's written in Rust. It's created and maintained by Astral, which is the same team behind the Ruff linter that's also becoming very popular. And we're going to look at Ruff in an upcoming tutorial as well. But in this video, we'll compare how a UV workflow compares to a standard workflow with pip and venv, and try to get a sense of why so many people are switching over to using this as their default. So with that said, let's go ahead and get started. All right, so first let's get UV installed on our system. There are a few different ways to install this, and I'll show you the one that I'm going to use, but also mention some alternatives. I'm on a Mac, and I like using Homebrew, so that's the method that I'm going to use here, and it's probably the easiest way if you already have Homebrew set up. But I'm also going to leave a link to this installation page in the description section below so that you can see the other ways that we can install this here. So for example, you can see that they have a standalone installer with just using a curl command on Mac or Linux. On Windows, you can run a PowerShell command, and then they have a bunch of different options here as well. But like I said, I'm going to be using the Homebrew option. So let me go back to my terminal here, and I'm going to install this using Homebrew, and I'll just say brew install UV. And once it says that's installed, I should be able to test this just by running UV, and we can see there that we get a list of all the commands that we can use with this. So that is installed and it's working. So now that we have UV installed, let's take a look at how it's used compared to the traditional tools that we might be more familiar with. So if I were to start working on a new Python project, here's basically what I normally would have done. So I would create a directory for my project. So I'm going to create a directory here, and I'll just call this old way, and then I will cd into that directory. And then probably one of the first things that you'd want to do is create a new virtual environment. So I would do something like Python 3, and I would use venv here. I'll just create a virtual environment called .venv. Now, if you're not familiar with virtual environments, don't worry about it. I'm just showing you the old way for now, and we'll look at the UV way, which is a lot simpler here in just a second. So I'm going to create this virtual environment here, and then we'd want to activate that virtual environment. So I'm on a Mac, so I would say I would source that, and that is going to be in the bin directory, activate, and we can see I have my terminal set up here to show me when I'm within a virtual environment, so we can see that that is active. And then normally we would just use pip to install whatever packages that we wanted on this new project. So let's say that I wanted to use Flask and request. So I would say pip install Flask requests, and then we would go about it that way. And we can see that just took a couple of seconds there. And then after we had whatever packages we wanted installed, then we would create the project structure for this new project. So for now, let's just create a simple main.py file. So let me go ahead and clear my screen here. I'll just do a touch main.py, which just creates a blank main.py file. And now let me list everything off in my directory here. So we can see that we have our virtual environment here, .env, and our Python file. And after I worked on my script here for a bit, I'd likely want to create a requirements file so that I can reproduce this project and share it with other people. So to do that, using the old way, using pip, I would say pip freeze, and then I would redirect this to a requirements.txt file. And if we look at this file, so I will just cat that out, then we can see that it lists all of our dependencies here of the packages that we installed. And we only installed Flask and request, but both of those depend on other packages of their own. So that's why we're seeing additional dependencies listed here. So then, If I pass this off to someone else, then they could recreate my project by creating and activating their own virtual environment and then installing the dependencies from this requirements.txt file that I have here. So that is a lot of steps, and it's not exactly the most intuitive process, especially for newcomers. So now let's see how this compares to using UV. So I'm going to go up one directory here back to my desktop, and we can see that we just have that old way project there. And now let's create a new project using UV. So instead of creating a new directory from scratch like I did before, I can instead let UV do that for me just by saying UV init, and we'll call this new app. So I'll run that. We can see that it initialized a project. And now if I cd into this new application here, and just a quick side note, if you already had a project directory but didn't create it using UV, then you could also cd into that directory and just run UV init without the directory name, and it will set up the directory you're currently using as a new application. And I didn't add any additional options to init when I created this, but UV does have a few different project types to choose from when initializing a project. So first there is the app option, and app is the default. So this is what was run when I just created my new project here. And like I said, this is the default. This is what I use most often. It creates a simple project structure for applications, scripts, web servers, and things like that. But there is also lib. And lib creates a project that is designed to be built and distributed as a Python package. I'd say most of us will be using the app default, but the option to create distributable Python packages is there if you're curious. So let me clear this out. Okay, so now let's look at what UV created for us with the default init for an application. So if I list all the files here, so first we have a git directory and a git ignore file. So UV automatically initializes a git repository for us, which is nice because most of us will want to track our code within version control anyway. The git ignore file has some common Python specific files that we typically don't want to track in Git, like cache files and the virtual environment. There's also a Python version file, which contains the Python version this project is configured to use. UV uses this to ensure that we're working with a consistent Python version as we're building this application. Right now, it probably contains the version of Python that we have installed on our system, but we can change this if needed. And then we have a README file, which is currently empty, but this is where you typically add documentation about your project. And then this main.py file here is a simple starter Python file for our application. UV creates this as a placeholder where we can begin writing our code. And finally, we have the pyproject.toml file, which is a modern way to configure Python projects. So let's take a quick look at that. I'm just going to go ahead and open up this entire project within VS Code. Okay, and now let me open up that pyproject.toml file that we saw before. So this has some basic information about our application, and at the bottom we can see it's listing our dependencies. Right now it's an empty list because we haven't added any packages that we're going to use for this application yet. Now, this is normally where we'd create and activate our virtual environment, but we don't need to do that here. UV will handle that for us automatically the first time that we run a command that actually needs it. So let's add those packages in that we used in our last example. So I'm going to go back to the terminal here. So now I'm going to install Flash and request like we did before, but instead of pip, I'm going to use UV add. So I'll say UV add Flask and request, and if I run that, then we can see that finishes up. It was a bit quicker than the pip installation was. And also, if I look towards the top here, we can see that it tells us the Python interpreter that it's using, and also detected that we need a virtual environment. So it created this .venv directory here, right here for us in our project. And then it installs Flask and request into that environment. And there are a couple other things that it did here as well. If I open that project back up, then we can see that it also updated our pyproject.toml file here to list Flask and request as dependencies. Another thing is that it created this uv.lock file for us. So let me open this up. And this lock file records the exact versions of all the packages installed, including subdependencies. So this ensures that your environment is perfectly reproducible. And it does all of that without us creating or activating any virtual environments. So basically it helps to prevent the classic problem of it working on one machine and not working on another because of some small discrepancy somewhere. And UV also has this nice feature here for visualizing and understanding our dependencies. So if I wanted to see a tree of my dependencies to see what relies on what, then I could just run UV tree here within my project. And we can see that our two main ones here are Flask and Request. And within Flask, these are the subdependencies here. And with Request, these are the subdependencies here. Okay, so now let's say that we work on our application for a while and now we want to run it. How would we do that from the command line if that virtual environment isn't activated? So from an IDE, this should be fairly simple. For example, let me open up that main.py file here within VS Code. So I'll open this up. So within most IDEs, you should have an easy way to find virtual environments within your current project. Mine automatically selects virtual environments inside of my projects if they exist, but we actually opened this project before that environment was created. So to select it, I just have to navigate down here to the bottom right, and we can see that it's using this 3.13 here, and I'm just going to have it select this virtual environment here within my directory. And just to make sure that this works, let's print out the Python executable that's executing our script. That way we can be sure that it's using the correct environment. So to do this, I'll just import sys, and then where we are printing out here, I will print out sys.executable. So now if I save this and run it within VS Code, then we can see here that it is using that correct Python virtual environment. So we're within our new app and our virtual environment here. So we're able to run this easily from an IDE, but now let's go back to our terminal and see how we would run it from there. So let me clear out my terminal here. And actually, I never deactivated this virtual environment from before. Glad that didn't screw anything up. Let me go ahead and deactivate that really quick. Okay, so now with UV, we're not in that same paradigm of having our environment active at all times. Instead, we're going to let UV handle that for us. So instead of doing something like Python main.py, we're going to instead say UV run main.py. And if I run this, then we can see that we don't have any virtual environments active right now, but UV runs the code and automatically uses that virtual environment that it created earlier. But now, let me show you something that's pretty impressive. So let's say that the virtual environment gets removed or deleted. So I'll go ahead and just delete that completely from my project. So I will say remove that virtual environment. And now we can see that there is no virtual environment here. And normally this would screw us up. We'd have to go in and create this environment again, activate it, and then install the packages to run our code, and then finally be able to run our code. But all of the information that we need to run this code is in our pyproject and lock files. So with UV, if I just try to run this again with UV run main.py, if I run this, then we can see that it runs that just fine. And what it did was it saw that we didn't have a virtual environment, so it created that for us. Then it installed all of those packages very quickly, and then it ran the code for us, all with one command. And not only that, but it was extremely fast as well, much faster than if we'd done this with pip and venv. And we don't even need to run that main.py file to get it to create our environment and install those dependencies. So if I were to pass this off to someone and they wanted to get their environment ready without running the application, then they could simply use UV sync. And I'll show how this works. So first, let me delete that virtual environment again. So it's not within our project. And now if I pass this off to someone and they have this on their machine, then they can simply run UV sync. And when they run that, we can see that it recreated the exact same environment using the UV lock file. And now if we wanted to remove a dependency, then I could just say UV remove Flask. And if I run that, it takes that off. And that would remove that package and update the pyproject and lock file. And then they could simply send that back to me without their virtual environment. And I could run UV sync and get synced up with those dependencies. So I find all of this a lot easier, especially for beginners. Instead of running 5 to 6 different commands and having to understand virtual environments, we've got a much more streamlined process that does all the complexity behind the scenes. And one of the biggest advantages that you'll notice with UV, especially over time, is its smart global caching system. So this means that if we have 10 different projects that all use the same version of Flask, UV only stores that Flask version and its dependencies once on our disk, which saves a lot of space. So your environments still remain completely isolated from each other, so there's no risk of conflicts there, but you get the disk space savings and major speed improvements when installing packages that you've used before. And that's especially noticeable when recreating environments or setting up new projects with familiar dependencies. Because with pip and venv, different virtual environments for different projects might contain duplicate copies of the same packages. So not only do you save disk space, but you also save on download times. And what used to take minutes with pip can be almost instantaneous with UV. And I know that there's a lot of new tools out there and it can get a bit overwhelming. So some of you may be thinking, okay, this looks cool, but I'm used to pip and I don't feel like learning a new tool right now. Well, the good thing about this is that UV provides a UV pip subcommand that acts as a direct, faster replacement for pip itself. So you can actually just keep using familiar commands if you want to transition gradually. So let me show you what I mean by that. So let's say that we go back to our previous project where we used pip and install another package. So let me switch over to that old way project that we created before. So in here, we haven't set this up with UV. If I look at the files in this directory, then we should only have our Python script and our requirements.txt file. So if I wanted to work on this, we could activate the environment and then use pip to install a package using pip. But UV has a pip command that behaves the same as pip, and if you have a virtual environment in your project already, then it will find that for you. So if I wanted to add NumPy, for example, then I could say UV and then pip install NumPy, and if I run that, then we can see that that installed. And now if I say UV pip list, then we can see that now we have Flask request and we also have NumPy there. So this pip subcommand here is nice for transitioning over to UV, but you do miss out on a lot of the functionality that makes UV so useful. So for example, since it's just doing what pip would do, it's not creating that pyproject or lock file in the background. So if I look in this directory, then we can see that we still only have the same files as before. So if I wanted this requirements.txt file to be up to date with the packages that we just installed, then we'd have to do a UV pip freeze to overwrite that. So the option to use pip commands is there if you want it, but I'd really recommend just getting started with using UV with its own commands, and I think you'll find it fairly easy to learn and use. Now, if I wanted to migrate this project here over to using UV's workflow instead of pip's, then I could just say UV init and run this. And that will create the project structure that we saw before. And then I'd have to add those packages from the requirements.txt file. So first, let me show that it created this project structure that we saw before. And now I want to add those packages from the requirements.txt file. To do that, I can just say uv add -r requirements.txt. And if I run that, it will install all of those. And if I look at the pyproject.toml file, then we can see that now all of those are listed in our dependencies. So at that point, if you wanted to move forward only using UV, then you could delete that requirements.txt file and rely solely on your pyproject and lock files. Okay, so now let me switch back over to the other directory that I created before in this new app. Now, another really cool feature of UV is that it can replace pipx for installing Python-based command line tools. Now, if you don't know what pipx does, it basically allows you to install Python command line tools that you can use anywhere on your system and not just in a specific project. So linters, formatters, things like that. Those are things that you'll likely just want to install once and use across multiple different projects, as opposed to installing them in every project individually. And we can also do this with UV. So for example, let's say that we wanted to install Ruff, which is a popular Python linter that's also made by Astral. So normally you might install this with pipx, but we can use UV instead. And this is a tool, so I can say UV tool install Ruff. And what this does is it installs Ruff in an isolated environment, but makes it available on your path. So let's confirm that that's installed and accessible from anywhere. I'm on a Mac, so I can do that by saying which Ruff. And we can see that it did install it here in my local bin directory of my home folder. So that should be available anywhere on the system. And Ruff is a linter, so with that installed, I can check my Python code. So if I wanted to check this project, I could say Ruff check. It says that all checks pass there. And if I had a more strict Ruff configuration, then that might come back with some improvements to change my code in ways that I want. And I'll be doing a Ruff tutorial in the near future also. So be sure that you're subscribed if you'd like to be notified when that's released. Okay, so it's just as easy to remove a tool. So let me clear my terminal here. So to remove a tool, I can say UV tool uninstall Ruff. And now if I check my system again for that Ruff command, we can see that it's not found. Now, one really cool thing about UV is that we don't even need to install these tools permanently on our system in order to use them. So if you just want to test out a tool or use it a few times for a specific task without permanently installing it, then we can do that by saying UV tool run. So let me clear this out. UV tool run. So if I wanted to run that same Ruff check command, then I could say Ruff check, and we can see that that works just like it did before. But if I search for Ruff on my system, then we can see that it's not installed. So that UV tool run command installs it in a temporary environment, runs it, and then cleans it up afterwards, which is super useful, and it does it all very quickly. And running different tools like this is very popular in UV. So they've actually made a shortcut for UV tool run, and that is UVX. So I can do the same thing just by saying UVX Ruff check. And that is the same thing as this UV tool run Ruff check. So if I run that, we can see we get the same thing. If I search for Ruff, it's still not installed. So that is super useful for running tools without installing them, but I use Ruff a lot, so I'm actually going to go ahead and install that permanently. So I'll just go ahead and do that and keep that installed. And we can check the tools that we have installed by saying UV tool list, and we can see here that right now we only have Ruff, and we can upgrade those individually if you want, but most likely you'd probably want to update them all at once. To do this, I could say UV tool upgrade, and then we could just do a -- all here. If I run that, we can see that there's nothing to upgrade since we just installed that. So I really like UV's tool integration here. It's taking all of these things that used to be separate tools like pip, pipx, and virtual environments and making them feel naturally like they belonged as a single tool to begin with. And there's even more that UV can do that we haven't covered. So it has ways of managing different Python versions, has commands for building and uploading your own Python packages to PyPI, and even has some features designed to help build optimized Docker containers. But those are things that we could cover in a more advanced tutorial if anyone is interested in that. But I think what we went over here covers the majority of what most of you will use UV for. I've been using it myself for some time now and really don't see myself going back to using pip or virtual environments the way that I was before. It's also what I'm going to be using in future videos. So I wanted to make this quick tutorial that I could point people towards if they see me using UV in a future video and have questions about that or why I'm using that over pip. But with that said, I think that's going to do it for this video. Hopefully now you feel like you have a good idea of how UV works and how it can simplify your Python package management. We've seen how it replaces multiple tools with a single interface and how it can be dramatically faster than those traditional tools. Now, in a future video, I'm going to be covering Ruff, which is a linter built by the same team, and that's another tool that I've migrated over to using in my daily workflow. So big props to the team at Astral because they've definitely put out some great tools lately that have become super popular in the Python community. But if anyone has any questions about what we covered in this video, then feel free to ask in the comments section below, and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. Also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon or YouTube, and there are links to those pages in the description section below. Be sure to subscribe for future videos, and thank you all for watching.